We are now going to start unit number 2, connecting tables. There's only one lesson in this unit, and in this lesson we're going to look at the differences between the different types of joins, the inner, left outer, right outer, text, and referential join. And also we will look at a standard union and a union with constant values, and which one is the recommended way of joining analytic views or tables. So I'm going to show you some examples of joins in this lesson, and we are going to use these three tables for our examples. So we have the fact table, which is the sales orders, customers, and state. So the state is connected to the customer, and the customer will be connected to the sales order. However, you're going to notice that order number 8 does not have a customer master record. So if this is my order number 8, you can see it doesn't have 77 customer ID over here. The other thing you will notice is that customer Tom does not have any orders. So Tom is right here, and Tom, which is customer ID 3, does not have an entry in the sales order table. And the state Texas does not have a description. So this is my state table where I have the names of the states and the descriptions of those states, and TX does not have an entry in this one. Also, we don't have any customer that actually resides in Alabama. So we don't have AL anywhere. So we're going to cover inner, left outer, right outer, full outer, text join, referential join, and union. The full outer join is no longer available in this version of SAP HANA. This is a summary of all the different types of joins in SAP HANA. So the inner join over here is like an intersection between the two tables. So you will only see the facts with matching dimensions. On the other side, facts without any dimensions will be excluded, because remember, it is an intersection between those two tables. So whatever is common in those two tables will be shown. In this case, the join is always executed. Then we have the left outer join. So in the left outer join, you will see everything from the left table. For example, if our left table is the fact table itself, then you will see all the posted facts, whether there is a matching dimension in the right table or not. So in this case, dimensions without any fact entries, if that's the left table, will be excluded. And this does give you a better performance than the other joins. We also have a right outer join, which is similar to a left outer join, except you will see everything from the right table. We have the referential join, and the referential join is like an inner join, which can be used for attribute views. And in this case, referential integrity is enforced. An example of this would be a data foundation for the header item relation. So you have two tables, the header table and the item table. So you have to make sure that 100% of the header entries are available in the item table as well. Another point to note is that referential joins are only executed when fields from both the tables are requested. So for example, if a field is selected from the right table, it will just be an inner join, okay? And if no fields from the right table are selected, then it acts like to a left outer join. You have to make sure, or at least you have to guarantee, that for each row in one table there's at least one join partner in the other table. That's when you can use a referential join. Otherwise you will get wrong values. The last one over here is a text join, and this is specifically for an SAP dimension table joined to a text table, so you can look at the descriptions of something that you have in your left table. Also used for language translations. So for example, you might have texts in different languages for a product. So then you can use a text join and you can see the description for your material, which would be filtered by the session language. So this is a SAP specific join, text join. Let's look at our next slide. So here we can give you some examples as well. So this is an attribute view, and what we've done is we have two tables, a customer and state. So I've joined the state to state with an inner join, as you can see at the bottom. So if I run this query right now, okay, what you're going to see is that it's going to miss out on Tom and Bob from the right side, from the left-hand table, and the reason is because this is an inner join, and an inner join is an intersection of both these tables. So whatever is common in this table, it will be shown. Now because we only have Michigan, which is common, therefore you're only going to see Werner and Mark. So here we have another example. This time we are using an analytical view. So we have the same inner join with an analytical view, because the analytical view will also have your fact table. So this is my fact table, the sales orders, my customer table, and my state table over here. So if it's an inner join, you can see that we are missing out on order ID 4 and 8. So you will not see these two amounts in your result set, because inner join is an intersection, so it will only show you the common elements of all these tables. So in this case you might lose the facts. So here we have design time filters that can be applied, and it's worth noting that design time filters are applied before the join is executed. So on the customer table I've added a filter, a condition, which is age is less than 13. So obviously it's going to show you everything, all the ages which are less than 13. So we're only getting the 3 records, and for the state we've said state is equal to Michigan, therefore we only get 1 over here. So because the filters are applied before the join is executed, you're only going to see 2 records, just like this one over here. This is an example of a left outer join. So I've got an attribute view, and I've connected the state of the customer to state of the state table with a left outer join. So we are going to see everything from the left table this time. So as you can see, you will get some blanks over here, and the reason why you're getting these blanks is because there's no matches in the right table for Texas, because as I mentioned right in the beginning, we do not have a Texas entry in the state table. Again, this is the left outer join, this time using an analytic view. So let's look at the results. So we will see everything from the left table. So all the facts are shown, but you can see in this case we have Texas, so it's missing the text from the right table. And also we do not have any customer 77 over here in our customer table, therefore it's a blank. Okay, but you still see the facts. So you will see all the facts, but the dimension information might be missing if you have a left outer join in this scenario. So it's saying customer Tom is not returned due to no corresponding sales item record in the sales order table, which is what we see over here. So this is an interesting one, and it enforces the concept that filters are applied to both the tables before the join is executed. So as you can see on the first table, we have the same filter applied like in the previous example. Age is less than 13, so we have the 3 records. State is Michigan, okay? But because this is a left outer join, you will see everything from the left table, which is the customer table over here. Okay, so you will get these 3 records, although for Tom we do not have information about this state, because that state information does not exist in the filtered values of the state table. Right outer join is similar to a left outer join. The difference here is we will see everything from the right table, even if those values do not exist in the left table. So you will see everything. For example, if this was a fact table on the right, you will see all the facts but not the dimensions. Or if you had the fact table over here, then you will see all the dimensions but not necessarily all the facts. So this is an example that I was just talking about. So as you can see over here, for Alabama we don't have any facts, but because this is in our right table, it's a right outer join, that's why it will be included in the result set, okay? Because we do have Alabama in our state table. And this one is the special join, and it's called the text join. So here what I've done is I've got a table called MARA, which is our SAP MARA table. Material number is joined to the material number of the texts of MARA, okay? And we have a language key over here, so we might have different translations of this material number depending on the language. So I've created a text join. They act as a left outer join, can be used with SAP tables where language column express is present. So then what you can do is you can specify the description mapping for that dimension. So this is the text join for multilingual reporting, because you can have text in different languages for the same material key. The user language that is going to be used for the descriptions it will be filtered at runtime. So this might be your session language that you're using. And then the last one over here is the referential join, and we've already talked about this, that each entry in the left table definitely must exist in the right table because referential integrity is enforced. This a good example for this would be the example I gave you earlier, which was if you have a header and item table, then you want to make sure that you definitely have a header for each and every item. So it's like an inner join when the join is executed. Only available in the OLAP engine. Okay, so this is available for analytic views. Okay, so we're looking at an example of a referential join for an attribute view. So we have selected the customer ID, customer name, state, age, surname, state name, and as you can see, it's not showing us Texas over here because it has to exist in both these tables. It acts like an inner join. There's an important note at the bottom. It's only available for the OLAP engine. Now, if you remember, OLAP engine is used for the analytic views. So if you're just testing the attribute view outside of the analytic view, then it becomes an inner join, not a referential join. Okay, because remember, it's only used in the OLAP engine. So as a result, Tom and Bob will not be returned. In this example, we can see what happens when you use referential join in an analytic view. So on the top, you can see the query that we're running, which is the same as in the previous example. The difference here is that we also have the amount, which is it's an analytic view. So customer 77, which did not exist in the other table, Tom and Bob are not returned because customer ID is a joined key field resulting in an inner join. Bob does not have any corresponding Texas description as shown in the previous tables, and Tom has no corresponding facts. So because of that, you only get those two records. Tom is not returned due to no corresponding facts in the sales table. The amount that you see over here includes the facts for the customer 77 and Bob, even though in the master data records do not exist, and this is because only non-key fields are selected from the left table, so all joins to the other tables will be omitted. The other thing that we're looking at over here is you have to be careful when using a referential join because it assumes that referential integrity has been enforced. Okay, so referential integrity is not enforced if you're just using values from just one table. In that case, it does not act as a referential join. It acts like an inner join. Another caution over here is not to use a join in a calculation view, in the graphical calculation view. So if you want to create a join between two analytic views, the recommendation is not to use a join but use a union instead. So here we have some facts about the unions within SAP HANA. They are used to combine the result set of two or more select statements. The union operation is popular for combining, this is an example actually, where you can combine planning and actual values in a COPA type of scenario. They're not supported in attribute and analytic views for obvious reasons because analytic views do not do a union. For that you need a calculation view where you can combine two or more analytic views. One thing to remember is that if you're using a script-based calculation view and not a graphical calculation view, so you have to use the CE union all function. In that case, you can only have two input sources, for example, two analytic views. So you can't have more than that. Avoid joining analytic views. So use unions with constant values. So unions with constant values are supported in the graphical calculation views. So here we're going to look at an example of a standard union. In this example, we have two analytic views with a field called flag. So in the first analytic view, we have A, and then we have P, for example. So this could be actuals and planning. And then once you do a union, a standard union that is, you will see all the flags on the right hand side, and if you run a query, you will see the result after aggregation, just like this one over here. A better option is to use constant values instead. So if I go back, instead of using the flags over here, we can use constant values for the union. So you can see the difference. Well, we only have two fields in the analytic view, amount P and amount A, and for the amount P over here we have a constant value of 0, constant value of 0 for amount A. So when you do the aggregation, you get the result after aggregation. So this is a better way to do a union with constant values, and this is the recommended way in SAP HANA. So that is the end of unit number 2. We've looked at the different types of joins and some examples. Also, we've looked at the differences between a standard union and a union with constant values.